Right, just for you, Sage, you can go ahead and join the Nevermind 101 class, so that way you can get alerts from me and everything. I'm about to send the link for my YouTube page, so you can check out the video. Okay.
All right, so these are your different types of transformations that can happen to a function. Now, this function can be a quadratic, value, exponential, so on and so forth, or it could just be a general random picture. Okay? But whatever the function is, if they have the function plus 2, plus 4, plus 6, that means that original function is moving that many units up. If it's minus, that means it's that many units moving down. If that plus 3 or that plus 6 is inside the parentheses with the x of the function, then that means it moves to the left. Do not forget on the inside is the opposite. When it's negative, it moves to the right. If there is a negative inside with the x, that means you're making all your x's negative, which means you're flipping over the y-axis. If the negative's on the outside, that means you're making all your y's negative, so you're flipping it over the x-axis. Sorry, not flipping, let's use proper words. Reflecting, reflection, you're translating it, not moving, okay? Terminology, my bad. And then if you have a number attached to the x, that means you're stretching it horizontally by the factor of 1 over q. Do not forget on the inside, it's the reciprocal. And if the number's on the outside of the function of parentheses, whatever, it stretches it vertically by a factor of p. All familiar? Okay. So what we're going to do, is pretty much that's like the last little bit, refresh your memory on the transformations. We're going to do a whole bunch of examples, okay? A whole bunch of examples, just to make sure we're good. Okay. So you had to match the graphs at the bottom of the page to the function. All right? So that f of minus 2 means what? You drop it down 2. And a lot of times, if you just select like one point and use that point as a reference, it makes it a little bit easier, okay? So, like using maybe this point, like that maximum point, you can even slide it over to make it a little easier for you. So it's about like 2, 2. You can use that as a little bit of reference. This is what I did when I did this. So I gotta move that down 2 units. So the only graph that does it, and I don't change the size, do I? No. So it should look the exact same, it just should be down 2 units. So which one is that? H. Very good. Now the second one, f of 2x, means that I have to do what to it? Stretch it horizontally by a factor of what? 1/2. Remember, if it's stretching horizontally, it's by a factor of 1 over q. Q is 2, so it's going to be 1/2. All right? Which means that if I'm stretching it horizontally by a factor of 1/2, that basically means that all of my x's are going to get what? Smaller. They're going to be divided by 2, so that means it's actually going to come in some. Okay, because think about it. The 2 affects your x's. So we're going to scale factor of 1/2. So that means that we're going to multiply all of our x's by 1/2. Well, this little reference point I had that's at about 2, 2 is now going to turn into what? 1, 2. So it's going to get skinnier. Doesn't move up or down or anything like that. And so that answer is what? B. That's the only one that's skinnier that didn't move anywhere else. B. Now 3. I guess it should be right. H and then B. Now number 3, I got negative f of x plus 2. Okay? You do any type of reflections and stretching first before you move any left or right. Okay? This is kind of a good rule of thumb. Okay? And I hope y'all won't get to like, trig functions and stuff like that. So the negative means I flip it how? Or reflect it how? Over the x-axis because I got to make my y's negative. So now this thing is going to point up, and then on top of that, I'm moving 2 to the left. So this point is now going to be down here, and I got to move to the left 2 units. So I'm looking for an upside down, parabola looking thing where that little peak is at 0, 2, which is 0, negative 2, which is what? G. Okay? 4, I got 2f of negative x. So I've got to do what to this problem? Stretch it by a factor of, which is 2. So stretch it vertically by a factor of 2, and then what? Flip it over the y. And then flip it over the y. So if I stretch it by a factor of 2, then that means that all my y's can multiply by 2. So this point right here, 2 is now going to be at 2, 4, and then I got to flip it, so it's going to be over here. Which one is that? F. F of x divided by 2. Don't let that throw you off. That's the same thing as saying 1/2 f of x. That's all that's saying. You can pull that, make it to the fraction out front and then the function. So 1/2 means I'm stretching which way, vertically or horizontally? Because that doesn't matter when you write it on your exam. Vertically, by a factor of 1/2. So that means that all of my y's are going to get multiplied by 1/2. So this is going to go down. What answer? C. This one, f of x minus 2 means I move right 2. So this point is not going to be here, and it doesn't get any bigger or smaller. So the answer is A. Same concept as before. This can be written as 1/2 x on the inside, and the negative on the outside means what? What's the negative on the outside mean? Flex over the x-axis, so it's upside down, and then it's going to be stretched which way? Horizontally by a factor of 2. So that means that all of my x's are going to get multiplied by 2. It's going to be upside down. Which one? E. Last 2. The negative on the inside means I flip it, reflect it over the y, and then I got to move it up 2. Which one is it? I. And process of elimination leaves us with D being the last one. Okay? Something that honestly, like I said, I like to use that reference point. So in that way, where's that point? What's happening? Okay. If you're wondering, is there matching on the exam? I have seen a few exams where there has been a matching. Okay? So, and then there's like 3 matching, and there were 6 points if you get one wrong, you just 2. So just gotta be careful. All right, here we go. I'm back. Flip over. I have no back. You're performing these different types of transformations to this graph on the same graph. Okay? So if you got colors that you want to use, I have some colored pencils and markers over there. Just be aware if you use markers and you mess up, you can't erase it. Okay? Let's try to get this done. Let's do this together, actually. Let's do this together. So I want to make sure that I can at least get through. Oh, but no, what else was there? Now, if I want you guys to the next one. What does the plus 4 mean?
Go up 4,
Go up 4. So that means every point, 1, 2, 3, 4 goes up 4. 1, 2, 3, 4, up 4. Okay? If they give you points, they're using that as a reference. They give you points, they're using that as a reference. F of x minus 2 means what? It's outside of parentheses. Down 2, that's right. So everything goes down 2. Down 2. Down 2. Down 2. What's the purple mean? Reflect over the x-axis because I'm making my y's negative. So everything gets flipped over the x-axis. Now I got a question. This point right here at -1, 0, it doesn't move. Because if it's on the line I'm reflecting over, it does not move. About paper exams is that if you're like, wait, I need to make sure I go like the right way, you can literally like turn your paper and make sure it looks. Right? If you don't have colors, make sure that you're labeling, like this one was C, the other one was B, so on and so forth. So when you go back and look at it, you won't be confused. D means what? Y's are by 2 because I'm stretching it vertically by a factor of 2. So that means that all of my y points are going to get doubled. So 2, 2 is now at 2, 4. Negative 1, 0 is where? Negative 1, 0. Because if 0 multiplied 0 by 2 is still 0. This point at negative 3, 3 is now going to be at negative 3, 6. And this point at negative 6, negative 2 is going to be at negative 6, negative 4. It just gets doubled. To stretch it, literally. It should look like you took the edges and pulled them up and down. And the last one, okay, the big old mess. F of 2x means stretch horizontally by a factor of 1/2. So that means that all of your x's are going to get multiplied by a factor of 1/2. So this point at 2, 2 is now going to be a 1, 2. The x's get multiplied by a factor of 1/2. This point at negative 1, 0 is now going to be a negative 1, negative 0.50. All your x's are going to get multiplied by 1/2. Negative 3, 3 is now going to be at negative 1.53. And this last point at negative 6, negative 2 is now going to be at negative 3, negative 2. A big old mess. Big old mess. Questions? Last one. I want you guys to actually write the function for G, Q, and H. They're all transformations of the f of x function, the red function. Okay? They're all transformations of that function. So when you're writing it, you're basically going to take that function and either add 3 or make it negative f of x, or put a 2, a minus 2 inside the parentheses, whatever. But when you actually have to write the function yourself and they don't give you like an x squared or an x cubed, this is what you work with. So how it was, on the front side, you see how they had the transformation written like that? That's what you're doing to these here. Identify what's happening and then write the function. So do G. I'll give you like a minute to figure out G. Then I want to check it just to make sure you guys are good before you go to H, E, Q. Who thinks they got it for G? Sarah. Very good. I took my original function and I literally just moved it up 2. I didn't make it skinny or I didn't make it bigger. And you know that because look at the red. It's 1, 1, 2, 2, 3, 3, 4, 4. I'm just going up steps of 1 over 1. Same thing's happening to that purple function. Okay? Take a few seconds to do H. Who thinks they got H? Harrison. H. Is the minus 4 on the outside? Making sure. Because yes, I'm moving down, and this as well did not get any bigger, any smaller. Now looking at some of your papers, it seems like a lot of you guys already did Q. Seems like a lot of you guys already did Q. Okay? And looking around, you've got to be careful. You've got to be careful. Because first off, if you want to use a reference point, that's what I would do. That is what I would do. I use the basic one, 1, 1. And I'm trying to figure out, okay, where does this correspond? Okay? Where does this correspond? Does this correspond to 1/2 1? or 1/2, or 2/1? Which one does it correspond to? With that being said, I'm gonna give you a second to think about y'all's answer. Who thinks they got it? Manny, what you get? F parentheses 2x. So you're saying I'm horizontally stretching this by a factor of 1/2. That's what you're saying. Okay. Well, let's see. That means that I'm multiplying all of my x values by half. So this is going to be at 1/2 1, right? And then 1, 2.
So it has to be f half x.
Or is it have to be 2x?
Wait, you can't give me all numbers. Okay. No, are you saying this? No, you're saying something different. Yeah.
Okay, half F parentheses X.
No!